back to another video. This is CodeTON round 6 of Codeforces, and we're going to solve the third problem, that is colorful table. So before moving on to the solution, as usual, let's try to understand the problem first. They are telling that we'll be given two integers n and k. N represents the size of integer array, that is a1, a2 up till an. They will give these numbers, and k represents the number of colors. That means every number from a1 to an will be in the range of 1 to k only. Suppose k value is 3 means a1 can be 1, a2 can be 2, an can be 3. It cannot be 4 or 5, something like that. Every number will be in the range of 1 to 3 only. So they will give this. What is our job? We have to define a two-dimensional array, that is a matrix, like an n by n square matrix, such that each cell, like if a cell is having a value of bij, you should fill it with the minimum of ai and aj. So let's say, for example, I am having a two-dimensional matrix here, and I am just taking this numbers as 1 and 2. Okay, so 1 2 you fill in row wise and 1 2 you fill in column wise. So this is what is the this 1 2, and the index of this is 1 1 1 2 2 1 and 2 2, right? In order to fill this cell of 1 2, I need to go to this is a1 and this is a2. Find the minimum of a1 and minimum of a2. That means what? It is same. Minimum of this and minimum of this. What is minimum of this? This is 1. You fill it here. Similarly, what is the minimum of a1 and a1? It is 1. 2 and 1, it is 1. And 2 and 2, it is 2. So we need to fill this. So left side it will be from 1 to n, right side it will be from 1 to n. After getting it, we just want to fill those integers with the minimum value of ai and aj. Now for each color from 1 to 2, like if k value is 2 means for each k from 1 and 2, we need to output what is the smallest rectangle in array B containing all cells. Smallest rectangle, we just want to know the sum of the width and height of the rectangle. So for example, if they give k value as 2, I need to output for k equal to 1 and k equal to 2. For k equal to 1, in this one, which is the smallest rectangle where all ones are available, that is row is number of rows is 2 and number of columns is 2. This column and this row, every ones are rectangle, right? If you take the rectangle, all ones are covered. So this is the smallest rectangle, so the size is 4, 2 plus 2. Now for 2, only this alone is enough, right? So what is the size of this? Width is 1 and height is 1, 1 plus 1 is 2. So this is the answer for it. Now this can be any different combination can come. So we just want to try out. Let's try to understand this with the help of an example. I hope the question is clear. Our main job is for after filling this matrix with the minimum values, for every 1 to k, we just want to find the smallest rectangle that is possible. If we do brute force, if we do iterate through all of the thing, time limit will get exceeded because of the constraints. So we need to find a better way to solve this problem. So let's understand. So let's say, for example, I am taking these numbers, that is, these are my numbers, okay? 1, 2, 3 and 4 are my k array. So that is 1, 2, 3, 4. K can be 5 or 6 also. For simplicity, let's assume k value as 4. This is also 1, 2, 3 and 4. Now, how do I fill this? So if 1 is the minimum number, I can say that if 1 is the minimum number, the row and column will be minimum, right? So this is 1, this is 1, this is 1, this is 1. If you compare 1 and 2, 1 is minimum, 1 and 3, 1 is minimum, 1 and this is minimum. So this is 1 is minimum. Now what is one more observation is, if it is the column and the row cell is at a diagonal, that is this is 2 2 and this is 3 3 and this is 4 4. For 4 4 it is 4 only, for 3 3 it is 3 only, for 2 2 it is 2 only. So I can directly write, right, this is 2, this is 3 and this is 4 without anything. If the smallest number I can directly write, and other numbers I can diagonally write it because the numbers are same. Now for 2 and 3, what is the smallest? It is 2. 2 and 4, what is the smallest? It is 2. 3 and 2, it is smallest is 2. 3 and 2 and 3 and 4, it is 3. And similarly for 4 and 2, it is 2. And 4 and 3, it is 3. So we got all these numbers here. So let's erase the unwanted ones. Now this is the matrix we got. What did they say? For each number, I need to find the length and the width sum of the smallest occurrence of these numbers. So for 1, since 1 is the smallest number and it is occurring at the starting, I can say that I need to take the entire matrix, right? So 4 is the size, 4 is the width and 4 is the height. I can take 4 plus 4 and this is 8. And for 2, so this is what is happening here. This is row and plus columns, number of rows plus number of columns. gave me the size of 1. For 2, I already know that someone before me has taken my one row, and if I know that someone before me have taken one row, then I need to subtract one row and subtract one column. From directly from this observation, I tell that that is row minus 1 plus column minus 1. Row minus 1 is how much? 3 plus 3, that is what? 6. Now I am applying the same logic here. Okay, if this is 3, let me try to decrease my value. That is 1 and 2 already took me, so row minus 2 plus column minus 2, right? So it is row minus 2 plus column minus 2, because I know 1 and 2 have already occupied, they are the minimum value. So whoever is coming before me, they might have took either 1 or 2 might have took that position, and for 3 in the row side also 1 and 2 might have took the position. So only these two I am reducing it, and I am keeping like 2 plus 2, that is 4. And 4 is the highest number. There are no numbers greater than me, there are only numbers less than me. Everyone might have took their own position at this moment, so I can just say that this is nothing but 1 only. Sorry, 1 plus 1, that is 2. So what is it? 1 row and 1 width. So we just found, what did we find here? For minimum, okay, I am filling the number of columns as same, number of rows as same, everything will be occupied. And diagonally what happens is all numbers are same. I don't know whether the information is useful for my final solution, I'm just observing. So in the diagonal all numbers are same, since we are taking the same number. And whenever the count increases, whenever the number increases, we understand that because someone in previously have took my position, someone is lesser than me, they might have took it. So I just want to move forward and tell that, okay, row minus 2, column minus 2, something like that. 1 can come or something, I don't know, I just wrote this one. Now in order to validate our point, 1 2 3 4 is ascending, so it's quite obvious, right? We need to find some other column so that we might get some other number. So let's say this example. What is this example in the question? That is this is the last test case. Last test case is 5 3 1 2 3 2 1. So 5 3 1 2 3 2 1, that means 5 numbers are there, every number will have a limit of 1 to 3. So how did they fill this? They filled it in this way, right? That is 1 2 3 2 1 and 1 2 3 2 1. What did I tell earlier? If it is the smallest number, you put 1, smallest number you put 1 1 1. So okay, they kept 1. Now what happens? We have to go to the diagonal, 1 2 3 2 1, that is also done. Now they filled the matrix, okay, some 2's came and some 3's came. Now we need to know what should we observe or infer from here. In this case, what can we observe? We understand that see, if 2 is here, we need to derive some solution, right? So for 1 we can't do anything. For 2, I understand that there is a 1 who is previously existing, and till when can I say that 2 is ending? So 2, if it is greater than 3 on the next bar, 2 will definitely come here. 2 is greater than or equal to 2. So if 2 is there, definitely it can come. But if 2 is greater than 1, it is not possible, because 1 will occupy here. So I say that it is the maximum farthest point. So how can I define it? I can say that it is the maximum distance from one number to the number that is greater than or equal to that 2. So the distance is what we need to find out. So this is from my observation. 2 3 2. What is the size of 2 3 2? It is 3, right? This 2 3 2, 3 boxes. Similarly, if row is there, then obviously column will be there. So we just have to do 2 into 3. That is, you are getting the number as 6. For 1, I am taking this number. For 3, I am taking this alone. Now what did we derive? Okay, if I want to get from one number to other number, what is the maximum possible? That is there 2. Suppose if 100 comes, I can definitely say that 2 will be part of this, right? Because of this column. So 2 will definitely be part. If 100 comes here, 100 also will come here. So because of this, 2 will also be part. So I need to calculate the distance from this 2 to 100. So what is the maximum possible value that is greater than or equal to that number? 100 is like the index. From this index to this index, what is the maximum possible value? That will be our final answer, where at least 1 2 exists and starting indexes exist. But can I say that we are taking only this one, right? What if 100 comes somewhere here? Is it possible? So let's say that 100 is somewhere here. Do I need to take this? Will the starting, I know the ending point is here, I know this is the midpoint. Should I take here this 100 is valid or not? So what will happen in this case? I know that 1 is occurring here, but before 1, if 100 comes, I can say that 2 will be part of it, right? So let's say 100 comes here. If 100 is somewhere here and 100 is somewhere here, I can say that for one, this 2 also is there. So I can say that there is a number that is greater than 2, so I can definitely populate in the column side for 2, right? So this will be the number. So starting from left, starting from right, what is the maximum possible value I can stretch myself? So if it's like a downhill here, these are a big number and this is also a big number. What is the and if this one, there is a deviation here, suppose this is 100 and this is 100 and this is 4 and this is 5 also, I need to take what is the maximum distance. If 5 comes here also, I need to take 2 to 5 and 2 to 4 if it exists. So because why 4 here? Because in row wise also that number will be taken, so that distance I need to calculate. So let's understand this with help of one more example. These are just, I derived it, I don't know whether it works or not. So let's take this example, 3 5 3 2 4. I think here it might be a bit more clear. So 3 5 3 2 4 means k value is 5, so k value is 1 2 3 4 5 for each thing I need to do, and 3 to 4 we got 3 2 4, and in the table it will be 3 to 4. What are the numbers we can get in this case? 3 is there, and for 2 what is the case? It is 2 here. For again it will be 3. We'll diagonally write first, it will be much easier, right? 3 to 4, and for 2 and 4 the smallest is 2, this is also smallest is 2, and 4 and 2 smallest is 2, 4 and 3 it's 3. What did we say earlier? Let's say for 3, are there any number greater than 3 so that this number will exist there? Yes, this number exists. So size is what? 3. Then definitely in square also it will be that 3. 3 plus 3 is 6. 6 is the answer here. Now for 2, is there any number that is there? Yes, greater number is also there, and greater number on the left side is also there. Why left side? Because in the row have the ability to destroy this value and tell that I am the smallest number. So this is 2. In column also I am telling it is the 2. So the distance is what? Again the same. So this is also 6. For 4, I am telling that right side no one is there. For 4 left side, any 100 or any big number greater than 4 is there? Not there. So this is the starting point and this is the ending point. So 1 plus 1 is what? This is 2. Is there 5 in the array? It is not there. So it's 0. Is 1 in the array? Not there. So it is 0. So answer is 0 6 x 2 0. So now we understood these are all the numbers. Let's try to figure out with some more bigger example with all the conditions and possible. So what I did here is, I hope you got the logic. We are trying to find the farthest distance and we are trying to the left farthest distance. So here in this case, these are the numbers, okay? 2 4 1. So these are the numbers, that is 2 4 1 3 2 1 4. K value is 5 and n value is 7. Okay, these are all the numbers we got. So what I did, I kept the number of rows here and column values also I gave, and I gave the index as 1 indexing so that it will be much more easier if we work with 1 indexing. Now let's understand that we just filled the matrix. We don't have to think about this because we already filled it. What will be the minimum value? Now what do? I say that before performing it, I don't know what is the starting and ending index of the array, right? If suppose 1 and 1 is there, I can definitely say that at the end 1 and 1, this one always exists and the starting one always exists. Before performing anything, I can say that if there is 1 here and if there is one more 1, I can definitely say that 1 will definitely exist there because that will intersect at some point. Even if you take 2 and 2, right? If 2 and 2 will definitely intersect at some point because it is a symmetrical matrix. It is a square. So if there is an end here, it will end here. If there is a start, 2 2. Same thing for 1 1 also, it is starting here, 1 1 also ending here. So I am just noting down what is the starting and ending index here. That is 1 3 6 is the starting index. So definitely the size will be at least 4. And for 2 it is at first index and it is the fifth index. So the size will be at least 5. 5 minus 1 plus 4, right? 5 minus 1 plus 1. For 3, there is only 1. So I take 4. Then for 4, it is 2 7. That is this 2 and this 7. So at least I can say 4 will start somewhere from here and 4 will end at that. So we know the size of this. Now, is there a possibility? I am asking that. Is there a possibility I can stretch myself? So for 1, is there a possibility? For 1, it is 3. What did it tell earlier? If there is someone who is better than me existing on the rightmost number. So 3 is existing, fine, 2 is existing, 1 is existing, but 4 is also existing here. If 4 is existing, I need to take this index, right? Because of this 4, there will be some 1 here, and this one will make sure it destroys the 4 value and tells it is the minimum value. So I can tell that there is a number that is greater than 1. So I tell that the new value will be 7. 7 is the index. Is there any number less than that, greater than that on the left side? Yes, 2 is the greater number. Even though 4 is greater, we need to take the farthest element. So 2. How can we take this 2? Because there is a 1 here, 2 for 1, 1 here. In the first column, it will be converted to 1. So I tell that 1 is the starting index. Let's go for 2. 2 is 1 and 5. Left side nothing is there. Now let's take for 2. Okay, for this also 2 is greater. So 7. So we take that this is also 7. How did we take 7? For this 2, right? When will we say that 2 will definitely come here? It is this 4. So no. This 2 is here. So according to this 2 will be there. We are taking the corresponding element and telling that there will definitely exist a number at last. If a number greater than me is coming, means in the column side, row side will definitely take care of it. So 1 to 7 I took 3. For 3, it will go till only 2. That is second index only. It won't go till this one. So 3 to 4 only. As you know, 2 for 1 3, 2 for 1 3. 3 can start from this 4 only. So 4 is the greatest number. So 2 is the starting index. So I am stretching it on the left side, and on the right side I can stretch it till 7. Same thing for 4. For 4 is the left side, nothing is there. For 4, this is the highest number, nothing possible, 2 7. So what is the solution for this? So 1 to 7 means there are 8 elements, right? 8 means number of elements are 8. Since we are taking row and column, it is 2 into 8, and that is 16. This is also 16, 1 to 7. And this is 2 to 7. Let's go for 3. 3 is interesting, right? That is from 2. This is the number, that is 3 is here. And till 7, 3 is also here. And always I can say that 1 2 3 4 5 6 7. It is the square matrix, or it will be some square matrix for sure, right? So this is what 1 2 3 4 5 6. That is 7 minus 2 6 5. 5 plus 1 is 6. 6 into 2 is 12. So 6 by 6 matrix. 7 6 5. So I think I made a mistake, right? 1 2 3 4 5 6. 1 2 3. Yeah, so as I told earlier, this number does not come. So where does it start? It starts from this square matrix, that is from 2 to 7, right? So this one, this is the matrix where all 3's are there. Here 3 is not there, so that was a mistake I did earlier. So yeah, this is a good example. And 2 to 7, same thing. 2 to 7, as you see, 4 will be part of this. 4 is here and 4 is here. We are just carrying the boundaries. 6 5. 5 plus 1 is 6. 6 is 12. 6 6 12 12. So answer is 1 2 3 4. 5 does not exist in the array for k equal to 5. So I tell that what do I say? This is 1, this is 2, this is 3, this is 4. For 5 I can simply output as 0. Now let's try to understand this with the help of the code. Now, so what did we initially do? We have to know that what are the corresponding index that are mapped, because we want to know what is the starting and ending index of it. If you know 1 and 4 also, that is fine, no problem. Why are we putting the starting indexes? If I have something like 100 and again 1 comes here, we may not encounter this 100. Like I'll tell you, like through the code. So we take the starting and ending index, we are noting it. For 1, we already noted like 3 and 6, right? Starting index is LA of I and ending index is RA of I. LA of I, min of this means I will always be the smallest element. I'm just tracking the I. R of A of I means it is the last number that is possible. SC dot insert of A of I means suppose 5 is not there here, right? I need to track it. What are the numbers are there? If number is not there, I need to output as 0. So that's why I'm using a set here. Now, why am I copying these elements? As you know, I want to know the minimum. Till left side, how much can I stretch? Till right side, how much can I stretch? I need to know the minimum value, that is the left side, and what is the maximum value that is possible. The index I'm meaning. Okay, I'm tracking only the index. Now, we might have a doubt, right? If I'm going for 1, I need to search for what will be my highest value. Then again I need to go for 2, then I need to search again. You can use it set and reduce the complexity to n log n, but still if you want to reduce, you can start from the last biggest element. If you start from 4, we very well know that there are we can't stretch it anywhere. Right side also we can't stretch, left side also we can't stretch, because we know that the 4 is the highest value that is possible. So for 4 we already know the index like 2 and 7. Now if 3 comes, I just want to compare it with 4's index, right? So for 3 means I already know my values are 4 4. Now if I earlier know that my force value, this, if this is I, this is I plus 1 means I can just convert my 4 to 2, right? Directly I can do, and this also maximum I can convert to 3. Okay, now if I want to do, I just want to refer my 3. I don't want to check for 3 and 4 who will be my maximum. If I 3 will have the highest possible. Highest possible is what? For 3 it is 2. Okay, let's understand that. For 2 it has 2 and it has 7. But the thing is, we already know that 2 is already occurring in first index. So I take the minimum of this. Either you take the minimum index of 2 or you take the minimum value of 3. Suppose 3 occurs here, it will be, let's say, index 0. We have to take 0, right? We should not take 2. So that's why we take the minimum of my present index wherever I am present, or my previous element. Who was my previous element? It was 3. If 3 is bigger, I'll take 3/4 index. Similarly for 1, either I can take 2's left index and 2's right index, the minimum of 2's left index and 2's right index, or if 1 is already having a number that is maximum, as I told earlier, right? If 1 is coming here, I don't have to take for 100. I can directly take for this number, this one. Okay, so that's why I take either my own 1's index or the maximum index that is possible in the array. So I am starting from 4. 1 will get the result of 2 3/4's maximum value, 2 3/4's left side's maximum value, 2 3/4's right side maximum value. So if we take 1, the right side of 1, if it exists, either the 1's right's maximum value or 2 3/4's maximum value. So I know that, right? So that is what SL of I and SL everything about. And lastly, we need to print the numbers from 1 to k. That is, if the number does not exist, we print 0, or we can just say that the highest possible number, that is SR of 1 minus the right side most part minus the left side most part, the one we marked in green, right, plus 1 into 2. So into 2, why? We are taking only one dimensional part, it will be in 2 dimensions, that's why. So this is the accepted solution. So please refer to this and see, the only thing that matters is approach. Implementation can be done in multiple ways. So this is one way. So what did we understand again? Like, we understood that what is the question. Then we came to know that, okay, if we want to we just tried with small number, we just know that diagonally every number is same. Now we know that, okay, that is not useful. Every number that is greater, if a number is keeping on increasing, if I am small on the left side, that number only will be placed on the right side also. So in this case, right, if 1 is there, 4 is greater, 1 only will be placed. 2 is there, 4 is greater, 2 only will be placed. We understood this scenario. Now we took one more example from the question and we wrote that it is 1 2 3 2 1 1 2 3 2 1. We understood how did this 2 came here with, because for 2, from where to where, we understood that 2 to 2 is possible, or any number greater than that is possible. So we are just finding out what is the maximum limit on left and right. So in order to proceed, our hypothesis is right, we just took one more example for 3 to 4 and checked that, okay, for 2, 3 and 4 is here, for 3 only till 4 is here, and for 4 it is alone. So it is correct. Now we take one more example which covers many scenarios that are there. Then how did we arrive at coding is, okay, this is there. If we directly implement it, time complexity gets increased. So what do is, we take the starting and ending point. For starting and ending point, pakka we know that, very well we know that the number of rows and columns will be there. But are there any limitations? Are there any extra things that we can do? If 1 1 is here, 100 comes means I take the 100 index directly, and left side also there, left side. So we just want to map what is the maximum potential. So since it's already computed, we come from the last already. For 4 we understood that it is the maximum, there is no more we can stretch. So 4 we take it as the base value. Then we go for 3, we take for 3's left and right, and is there a possibility we can take 4's maximum and 4's minimum also. So we'll merge what is the minimum and maximum. 2 we'll take for 3 and 4, which is already computed, and for 1 we take 2 3 4 or 1 2 3 4's maximum or 1's maximum. So we already compute earlier, and then we find out. Now if the number is not present in the array, we can just tell that it is 0, or else we are saying that 2 into the maximum minus minimum plus 1. So that gives the total number of elements. So that's all guys, and please let me know in the comments what you feel about the video, and please share your honest feedback. Thank you so much. We'll see you in the next video.